to the next module. I've posted the video from last week on manipulate, and apologies for not doing that sooner. So I'm going to start per usual with the simplest of slides, and let me share my screen. Okay, so starting from the main website, there are now these visualize slides. So really the point of today's lesson is just talking about how to take these, how to actually implement these grammar of graphics concepts. And so the two G's there are what ggplot actually stands for. It's the grammar of graphics. And really it's just the simple idea that as you build up a plot, you you iterate on it, starting with these things called aesthetics, which is kind of like what's your X column, what's your Y column, and then from those aesthetics, then you can say, okay, what kind of geometry do you want to apply? So is it going to be a scatter plot, a line graph, an area plot? And you can actually have similar aesthetics and generate different plots from them. So that will be, and then from that given plot object, you can then change the labels and all kinds of things from there. So really, it's just it's sort of an add-on to this exploratory data analysis. And then I finish just sharing with you. So ggplot is rendering static images that are really useful for things like PDFs and Word docs and basically anything that's not online and interactive. But it's really nice to be able to generate interactive plots that allows you to see things when you hover over a given data point or zoom in and out, let's say to a period of interest. So we're going to create we're going to take that ggplot object and then feed it to a plotly function called ggplotly, and then boom, it makes it interactive so that you can get those some of those features. And then finally, we're going to use this other package called dygraphs that tends to be a little bit more oriented for time series. And it's just the most cursory overview of this topic, just to give you a flavor for what's possible and some of the thinking behind it. And then I have further materials in the lesson to review. So I wanted to not spend too much time in the overview, and I want to dig into the actual doing of it. So I really don't have much in the way of slides for today, but that's intentional. So we're going to go over these packages, ggplot2, plotly, and dygraphs. And so that ggplot2 is the static, and plotly and dygraphs are just sort of some interactive HTML widgets libraries, which I'll talk about a little more too. And so again, what we're talking about with this, what does that mean when I say layers, and then adding things as we go? So previously, okay, so first we can define an aesthetic. This is part of this thinking with the ggplot, and that's where the first argument is the data that goes in of this function ggplot, which is in the ggplot2 library. And then the second argument is the aesthetic, so the mapping of the different axes, in this case, time and revenue. And then there's this plus operator, which is then adding potentially the next thing, and then we're adding geometry, in this case, of the line. So this could be a geom point, which would be a scatter plot. It could have different geometries that we'll look at. And you'll learn how to just map the aesthetics and then map the geometry. And then you can do other layers, like we can add a smooth layer that takes the line and then looks at a trend over the entire, let's say, time period on the x-axis and adds a smooth. So we can do that. That's one more layer that you've added on top of that plot. And then you can then add more customizations to that object with this plus operator. So you might notice that the plus is very similar to that pipe operator that we talked about last time. And really, this was Hadley Wickham's first big library that he made. So he would have now, in retrospect, rather had a pipe operator to update this object because it basically performs something very similar. But anyway, this is when you're using ggplot, you just use the plus operator instead of the pipe, but it has a very similar functionality. What is output on the left basically updates the function on the right. It's a ggplot object, so it actually operates under the hood as like something a little bit different. But yeah, you just use the plus when you're modifying the ggplot objects. And there is this whole base R way of plotting things. It does not have this consistency of thinking. So you actually get the most benefit by learning this, and then you can customize from there and then have a lot of reusability with different plotting types with the same thinking. So that's the most common way of doing this in the tidyverse, and I hope that we go through the exercise and it makes some sense. And similar to last time with using especially dplyr and tidyr, we went over a lot of the cheat sheets and used those as reference. And we're going to do the same. So everything you need to know about ggplot2 is somewhere on these 2 pages. It's only 2 pages. So I know it's small text, but we'll zoom in to this cheat sheet as we work through the exercises and generate a bunch of different plot types. So you can always get to this menu from the RStudio application under Help and then Cheat Sheets. Okay, so without further ado, let's go to the lesson. And we're going to kind of pick up where we left off last time and introduce a couple of other techniques with reading in a table. We're going to talk about using here and for a consistent way of referencing paths within your repository locally with your R code. And then show a read underscore CSV instead of read.csv. And we're actually going to read directly from the URL we used last time to get that ERDAP dataset, which before I downloaded it, and now I'm going to read it directly. And then we're going to go over creating these static plots with the ggplot2 and the grammar of graphics. And repetition is helpful, so I'm going to repeat what I have been saying earlier about these aesthetics. So the first argument is always the data with the ggplot function. And the second argument is the aesthetics of, okay, what are the dimensions in that data object that you want to visualize with the plot? And then we're always adding a geometry type. And there's all these different geom underscore functions to do these different visualizations. And then and we can layer those. So we can layer with a geom smooth. We can also start to understand when we look at this cheat sheet, which I'll go ahead and I think I have it opened up over here. And we can see that the way the cheat sheet is organized is there's these, graphical primitives. So that's if you just want to define a polygon or rectangle, basically not generally tied to a data frame that you're fundamentally plotting, but you can always add these sort of annotations within the plot. But the core data, if you have just one variable, you can generate a histogram. So that would be like some sort of frequency of something that you want to get a count on. So there's only, yeah, it's one variable. So we're only mapping one aesthetic in this case. And if it's continuous, then we would get something like a histogram. And then if we're mapping two variables, what kind of variables are they? So if it's a continuous x and a continuous y, then we might have something like a scatter plot, which would be a geom point. If it's a discrete x and a continuous y, which is what we're doing in the exercise, we have a regions, for instance, on the, or excuse me, we have sorry, we do a geom line. Sorry, we're doing a geom line when we have two variables and it's continuous. So we have an x and a y. And then we do we summarize by these discrete regions, and then we can do things like a box plot, or a violin plot, or a column, geom col plot. So this is broken up based on what kinds of input data are you trying to fundamentally visualize, and then what kinds of geometries are available. And then there are all these other arguments to each of these geometries saying, okay, alpha is the transparency, color is the outline color, fill is what is the color filled into the individual bars, and we can have groupings. So let's get into it before we talk too much about it. But anyway, so we're going to do a geom histogram, which is like basically one input variable there. We're going to then update with plotting a time series by different regions with different colors. We're going to update the labels. And then we're going to do this other thing called a facet wrap. So that's generating multiple plots by faceting with a given variable. And then we're going to go back and look at other different plot types, like looking at variation over time within a region. So as a box plot instead of a time series. So that would show like box and whiskers of like what's the mean versus how much does the value range within that mean. And then a violin plot is just shapes it like something hourglass or whatever the distribution of that data looks like to show, again, variation. And then we're going to change the theme of plots. And that's where you can get into a lot of very granular customization of what kinds of grid lines are showing up and what the margins look like and fonts and lots of stuff. And there are some pre-shipped themes, and we'll look at how they're constructed, and we'll use the theme classic as an example. And then we'll go into interactive online plotting with these libraries, Plotly and dygraphs I mentioned before. So these sections are organized accordingly, like 1, 2, and 3, the 3.1, 3.2, 3.3. And let's go ahead and go into here. So I'm gonna, for the sake of me being able to explain the code, I'm gonna just do a copy paste. When you go back on your own time and try to do this, it's actually a good idea for especially the functions to type them out as much as you can. And that really drives home like the syntax of these functions, what they expect if things don't work, and then you're kind of forced to contemplate it a little bit more in between. So I'm suggesting that you open up your rproj. So I have, let's see, on Finder, let's see, here I have it opened already, R3 exercises. And from last time, you might have a manipulate and a collaborate and an index. So we're just going to go ahead and create a new R Markdown file, new R Markdown, and we'll call this one visualize. And then we'll save it as visualize. And so now I'm in an R Markdown, and I can start to mimic, just try to run and make sure I can run things in the online lesson. So I'll see if I can split this screen so we can look at one and then the other. Okay, so to start, I'm just going to copy this so we can keep track of what little section we're on. So we're reading the data, and I'm going to delete all this other stuff. And then I'm going to insert an R chunk. So again, an R Markdown file is just some front matter, some chunks of code. In this case, a chunk is 3 backticks, fences, a code chunk, and then this, within the curly braces, it's saying, okay, let's use R to evaluate this chunk. Let's label it setup. We see the label here, chunk 1 setup. This one is unlabeled, so you don't see a label there. And then it has some arguments to include. Okay, so here I'm just going to create a chunk, and we're going to just copy this and paste it. And now I can run this line by line or the whole chunk at once. And I'm introducing this other library called here. And that's really nice because it's saying here starts here. Okay, so then you'll see this was our URL from last time of that ERDAP to get the data set. And then this is here. What does that do? So that prefixes it and gives me the full path. This is going back to making things really so that if somebody else clones your exercises repository onto their machine, this ensures that when they open it up and then run things, it works. What we haven't done is moved our markdowns into subfolders, but generally when you're running code within an R Markdown, it's using the working directory of whatever folder it's in. Using here looks for the R proj file either in the current folder or keeps on going up a folder, and then it sets that as the root of the project and then updates the paths accordingly. So if you're referencing a path using here, it will work regardless of where you move it. So maybe I think this is an important point for doing things. So let's see if I can demonstrate what I mean. So let's say I have a test folder, and then I file, save as, test. And then if I say get working directory here, and I just run this chunk, you see how this folder is test. So if I didn't use the here and I just said get this data here, and then read that, not reading it, but I could say file exists. And even though I see data, there's the file, CSV AC, false. So if I use the here, it's true. And that's because it goes and finds the rproj one folder up and then uses that as the prefix to the rest of the path that I give it. I know this is a little confusing at first, but it makes a huge difference for the portability of your project for others, as well as maintaining the sanity as you as things get more complicated later. So let's go back to our visualization. I'm just going to delete that little temporary folder that we used to demonstrate the here. And notice here we have the URL, and we're going to read directly. So we can read directly from the URL. We'll do the little trick. In this case, the read underscore CSV has slightly different arguments. We're going to say column names is false, and we're going to skip the first 2 lines because it was 2 lines that of the header. The first line was the name, and the second line was the units of that header. And then we're going to update it by taking the default arguments and just getting the names. And then we basically get our data frame of interest with all of those different columns like we had before. And then let's move on to actually doing some visualization now that we have some data. Okay, so with the grammar of graphics, it's again these principles of feeding the data, always first argument, setting up these aesthetics, and then adding in geometry, and then we get an output plot. And from the cheat sheet, we know we want a line plot. So we see this geom line, and it wants an X and a Y. That makes sense. And now we also get these other aesthetics that we can use that we'll use later. For now, let's keep it really simple. We're going to subset the data to selecting the columns of just time and total fisheries revenue. And then we're going to filter out where we have data, actual data values. Those start in 1981, whereas the original data set goes back to 1945. So let's create a new chunk. Well, first I'm going to keep track of where I'm at by adding adding some headers. So I'll just add these headers. So that's a second level header in Markdown with these 2 guys. And then this is a third level header. So that'll mimic this kind of look here. And then I'm going to create a new R chunk. And now let's go over this. So let's run this. And what we're seeing here is just a very simple table, extracting some data to do a very simple line plot. And then let's get another chunk to actually do the plotting. Or I can just keep going with this one. So we're going to take this data for the coast-wide data, and then we're going to feed this. So this is using the dplyr, meaning we could have also just run it like this. And I could actually just go ahead and directly plot it like this. So this would now work. So this gives us this plot over time. I set this to the P coast object because this pattern makes it a little easier to do some other stuff. Like I could insert some extra filtering or selection on a new line in between this data frame or tibble and then sending it to ggplot. I can, and then you'll see later how we can add some layers to it. So this is saying, take this data frame, set up these aesthetics, and notice that if I just run this, actually I don't get, it's not really, there's no data yet actually plotted because it doesn't know what geometry type. It just sets up the axes. But then I add the line and boom, there it shows up. Now, if I set it to an object, then I can show that object by default. And then if I knit this whole thing, our markdown now I can see that, okay, notice this is all in a single chunk. Here I'm getting some messages back, and then it's splitting up when it's asking for output to then it looks like it's a second chunk, but it's actually the same chunk. It's just that I'm getting some output in between, like this data table. So yeah, we can do things like we can echoes true, we can set the message equals false and the warning equals false, and that'll turn off these little messages saying like just as little, they're not errors, they're just informative. Yeah, so now that's turned off by setting this in the setup chunk. So these are just some, knitter is the underlying R package that helps R Markdown render these outputs, or knit or weave the markdown in the chunks of code. Okay, so we've got a simple ggplot output here. And let's see, should occasionally look at this chat to see if I'm losing folks. Okay, cool. Looks like some discussion about read.csv and read_csv. And I mentioned also in the notes that let's see. I just mentioned a little bit of that justification in the notes that I like read CSV because of the way it deals with factors. So it's probably in the link that Matt shared in the chat. So thank you for that. So the default is to take character strings and columns and but with the read.csv and turn those into something called factors, which add a layer of complexity that can be really frustrating to deal with. Okay, so let's now take the simple plot here, and then let's add another layer to it. So that's as simple as just taking that object and then adding, in this case, a geom smooth. So I'm going to copy this into third level header and insert another R chunk and copy this. All right, so now we see that, okay, cool, it adds this header. Well, you can look at this geom smooth. So I use my function F1 key to get the help on geom smooth, and I can see the arguments in here. So what is method? Okay, so method is a smoothing function. It can accept LM, which is linear model, a generalized linear model, a GAM, a low S. So you can play with different trend functions. Let's just try low S here. And okay, now it's actually, it's not a linear model. It's using data within a window and smoothing in between. So that gives you a sense of how to be able to add that stuff in pretty quickly and easily with these types of functions. Let's take an even simpler function than two axes, and let's just look at a single aesthetic. So what if you wanted to do like a histogram? So let's do that guy and insert an R chunk. And so I'll take the same data. So this is just these two 2 columns, and then I'll only set an X, and then we'll just send it to aesthetic, and then we'll send that to the geom histogram. And you see here we have a histogram. There's also a little message saying, okay, stat bin using bins equals 30. Pick a better value with bin width. Okay, so if we look at the geom histogram help, you can see that there are different stats and there's bin width. So we can mess with bin width, and that changes the width of the bin. So this is saying we're going to use 30 bins by default. But if we want to use it in units according to the x-axis, then unscaled x. So we're going to say, if we want to say bin width equals, let's say, looking at this x-axis, like, let's bin it by 100, and then run again. Okay, so we get a very different histogram. It's the same underlying data. We're just changing the width of the bins of that histogram to give you a sense of different geometry-specific arguments that apply. But again, the setup is the same. We set up some aesthetics and feed it to a new geom. All right, so let's go back to our line plot. And previously, we only plotted a single set of data, which is the total fisheries revenue. But this original data set actually had columns for Oregon, Washington, and California. And let's say we want to look at those over time. And we're looking at time series because this is the most common kind of, let's say, indicator data, is looking at an indicator over time. And so let's look at those other regions and try to plot those. And we're going to try to plot those with different colors. So that means that we actually have to take that original data and tidy it up because ggplot wants tidy data, meaning each observation is unique by row, and it's more of that long format where anything that varies is in its own dedicated column as it with the unique observation. So we don't have these things column-wise. So let's copy this guy. Well, let's see, I'm on this little section now. And I'll just give it a little header, add another R chunk. Let's copy this, and then let's slowly kind of discuss what's happening here. Okay, so this is a rehash of the manipulate, but it also reemphasizes how so much of any function that you're using, whether it's visualization or modeling, is really about needing to do that janitorial work I mentioned last time of manipulating the data to get it into a form of whatever function it is you're feeding. So we're going to use the stringer library and the tidyr library to go, stringer library to manipulate strings, tidyr library to pivot into a longer format from a wider format. So I'm going to just run these line by line so we can see what's up. So here's our original DAC, and I'm actually going to change this so we can look at this a little bit more easily. So I guess here's all of our columns. It's a tibble. Well, I'll stick with that. And then we can select the columns that starts with total fisheries revenue. So now we get the California, the coastwide, Oregon, and Washington. And then we can turn off the coastwide because we plotted that already. And now we're left with California, Oregon, Washington. And then we can now pivot longer. So if we look at that function from the tidyr package, F1, and then I can say, okay, so that data is coming from that data that I had left of the pipe operator. So that becomes the first argument of the pivot longer, so the data argument. And now the second argument is this minus time. And that's saying, okay, choose the columns to pivot. Well, if I say minus time, that's saying use all the other columns and pivot those, but keep time. Don't pivot that. Because each observation is unique by time. And we're going to take the names of the column names, and then and we're going to call that name, and then we're going to take the values and call that value after we pivot. So easier seen than said. So let's take a look at what that looks like now. So now we've pivoted our time. So we see 1945 is repeating, and then but those repeats are varying by the name, and there's no value for until we get to 1980, and then we're going to manipulate that name by replacing everything, getting rid of that prefix with nothing as the second argument, and then we're going to make it uppercase. So can now go, okay, let's take a look at what that looks like. Name. Oh, so I called it region, not name. So there we see the region. So we mutated to create a new column based on name. And then we also want to filter out so the exclamation is negation. So we filter on a condition to limit the rows. And I say exclamation is the not, where not is NA. So that says where we have a value that is not NA. And then we go from all these values being not a number to now it's filtered the rows. Now we're starting at 1981 because here's where we start to get a value. And then finally we select the columns that we really want, which are time, region, and value. So it didn't spit back out because I set it to a little D for data. And now we've got time, region, and value. Great. So this is what we want to plot. So we're going to set up a plot object that we're going to define, again, using ggplot. First argument is the data frame. Then we're going to set up these aesthetics. And what we're adding here is this group and color. I could have done it with just color, but it's kind of like we're grouping the data. That gets used in other things that we're not going to go into at the moment. But so these are the other aesthetics that we can manipulate on this geom line, and we're going to take advantage of basically of color, really. And then by changing the aesthetics and just adding these two aesthetics, that's the real difference besides the data formatting. And then we send it to the geometry line. And now we get what we want here, which is it's picking automatically these colors of California, Oregon, and Washington that are very different, red, blue, green, and it's showing us the variation over time. So if we summed those up, that would be analogous to what we did previously to get the coast-wide based on my understanding of the data set. So now we're getting a more granular view looking at what's kind of generally called a series of data with multiple types along that line plot. Okay. All right, now let's say we want to update the labels. So let's go ahead and run that. And insert a new chunk. And we're going to just operate on that original ggplot object. So we save the P region, and now we're going to add some customization using more ggplot functions. In this case, labs, which is short for labels. So this plot for the region object that we previously saved and showed here, we're going to operate again, and we see that we can set a title, an X label, and a Y label. And this is interesting here, the color. So these are actually analogous to the aesthetics. You see there's X, Y, and color is now region. So if we didn't have that, I just use the, well, actually I already defined this, so I'd have to run this. I overwrote the definition. If I didn't have the color and I just ran it without, so I'm commenting the stuff I don't want to actually run, it's still the old lowercase region. So yeah, that's how we can easily set labs and or labels. Okay, and then this is another little tricky thing, and this isn't the best example of doing this, but we're gonna use this other thing called facet wrap. So you might want to look at regional variation, not one on top of the other, but maybe as separate plots. So that's this thing called faceting. And we can take that same object and now facet wrap based on the variable of region. And what that's doing is now creating multiple plots based on the unique region. This is not the greatest example because region is already differentiated based on color. But if you had another variable like species, then we could show how those things, how it would be this plot, but for each species. So you can facet things too. And it gives you another dimension in which to generate plots. So yeah. Okay, let's keep on chugging along here, and let's look at like some different common data types. So let's look at a bar plot. And what's interesting here with the bar plot is if we look at the cheat sheet, there is a geom bar, but notice that the aesthetic, there's only an X. So that is that's a little bit different of discrete. There's not two variables. We want a discrete region. And what we want to look at is, let's say we want to look at the most recent year of data for a really simple bar plot, or column plot is actually the better term to associate with this geometry. So in this case, we're going to also grab some more manipulation stuff to get the most recent year of data. So let's grab this little chunk. And what we're going to do is we're going to use this glue library and the lubridate library. Glue to handle strings and nesting variables inside a string, and lubridate to use this like year function to get the maximum year. So we want to get the most recent year and show what's the regional data say about the most recent year. So if we look at this data table, okay, so it's just 3 regions, really simple. And let's say we want to plot that. So X is discrete, so meaning it's either Oregon, California, or Washington. And Y is continuous. And that's why this is a good data type that we can use, is this geom call. And then we can just spit that out. And then we can apply our labels on it, whoops, like before. Now what's interesting about this is that the fill that I use in the label in the region. So the aesthetic is fill, not color. So if I did color instead of fill, let's take a look at that. So you see that color is actually, in this case, it's the outline of the shape or the geometry. It's not the filled in color. So color is more like the line. And if the geometry has some interior, then that's the fill. So we want to actually vary it by fill. And I think the default color is transparent, so it doesn't default to having an outline. Okay, cool. All right, so let's look at another way to vary this, to show variation if of a continuous variable when we have multiple discrete variables along the x-axis. And then we'll use another little trick here. So I'm going to create another R chunk. And let's, so now we have this, we're going to do the same as before. Oops, I think I grabbed the wrong one. Oh, no. So yeah, so this one, in this case, what we want to do is we want to look at the variation within the region. So if we look at this, there's this year to year variability within a region. And there's another way to visualize that, which is like, well, what's the mean or average value for that given region? And then how much does it vary around that value? So that's classically done with a box plot. So we can take, this is the same, almost identical aesthetics as before, but now we're applying a geom box plot. So we're not limiting it to the most recent year. And then we're giving it a box plot. So if we look at that, so a box plot is this is the average, and then there are some like 70% or something quantiles. So that's a percentage of the values that fall within. Like we can look at the function to remind myself what those quantiles are. Box and whisker plot. So Tukey was the statistician who came up with that. And so the notch width, this is 50%. Somewhere in here, it's going to talk about what those values vary by. Yeah, so it's the first and third quartiles. So the data falls within the the 25 and 75% of the data falls within the box, and then the whiskers show all of the other data that are outliers outside of that. So it's a nice way to visualize the range within the region across the years all at once. And the other thing, so we can, again, just keep on adding the labels here. And then we notice that really this region is already displayed on the X. So we can drop this legend. And how do we do that? We say theme legend position none. So that looks a little strange, but basically it's telling it don't give it a legend, position it basically nowhere. And this theme we're going to come back to in a bit, but this is where all that granularity of your plot can take place, or you can use an existing theme. So yeah, there we go, looking at variation with the little box plot. And then let's look at some variation with a violin plot. And that just changes the shape. It's a little bit more intuitive because this is like the distribution. of each of the data. Takes a little bit more interpretation or a second to look at it, but yeah, we can play with the different geometry. And you see this violin plot here. So we're just getting that data, setting up the same aesthetics, and this is the only thing that changes from above is just the geometry. And there we have a violin plot. Now I save this violin plot because then we can just let's mess with a different theme to see what that does to give it a different look. So let's insert an R chunk, and then we'll run a different theme. And theme classic. So when we look at this, so okay, this is classic. It drops the grayish background to the plot, and it drops these little grid lines, and then we just see, okay, just a very simplistic view. Well, if we look, you can take any function and just paste that into the console, and it shows you a few really interesting things. So I didn't actually execute the function by giving it the parentheses. I just am spitting out the function. And this is the equivalent of saying theme classic, of defining the function. I could say this. That was the original. I could say theme Ben. So this is my little custom theme. And then this is creating a function that, so this is the original theme classic is just this basically. And it's doing this like replacement of the black and white theme with these other customizations. So if I run this and run this theme Ben, it's the same thing. And let's say actually I want to keep something or change something. I could have done like an input argument of like base size equals, let's say I want the text to be bigger, make it really big, monstrous. Theme size base says 20. So I'm going to use this input argument, and we get much bigger text. So there's a lot of customization you can do. I could actually say, like if I change the function inside here, and this is replace theme. Let me make this a little bit more readable by just indenting these things. Okay, so I could say, well, you know what? Actually, I want to keep the panel border. So I'm going to comment that out. And otherwise, it's turning it off by making an element blank. And then we could see what that looks like. So it keeps the border in versus turning that back on. So now the border's dropped. So anyway, just want to give you a flavor for how you can really get under the hood and create your own theme, tweak it from there. So I want to, before we finish talking about visualization, I also want to show how you can use this in an HTML page. And there's this amazing framework called HTML widgets. Python has something also called, I think, PyWidgets. But let's talk about interactive plots. Excuse me. So this is super cool. So let's make it interactive with this stuff. And I can take that this P region. So that was this guy. D region, P region is all the way up here with just the time series plot. Yeah, this guy. So we can take this ggplot and then make it interactive. And what does that mean? Well, because this is a rendered HTML website, I can hover over these points and see their values. I can download the plot as a PNG and see that and use it in a slide or something. This is a Plotly. This is all the stuff you get with Plotly. I can zoom in to a given part of this plot, or I could pan around from there. I could even turn on and off different time series if I just want to focus on things. So this is quite cool for really taking a close look at your data. And what's amazing is that you get this so cheaply. All you have to do is take that ggplot object and then feed it into this Plotly library's ggplotly function. So let's do that. So I'll insert an arm chunk. And then let's run this. And now we get this ggplotly, which is so cool. So I can just zoom in and turn on and off series and really examine this thing. And this is really reliant on this HTML widget framework, which is so cool. So it takes so much of the data visualization that's happening is on the web now, all the cool stuff. And like there's this guy, Mike Bostock, who, I don't know, 10 plus years ago, wrote a JavaScript library called D3, Data-Driven Documents. And there's been a bunch of spin-off visualizations using that core library. And this HTML widgets framework allows you to take those JavaScript visualizations, wrap it into a single R function, and then generate these visualizations in these 3 different contexts. So in RStudio, we can get a viewer pane, rendering from an R Markdown document into an HTML, and then later when we talk about interactive applications, also in a Shiny app in these 3 different contexts. And you can look in the showcase and there's tons of visualizations. So we're gonna go over Leaflet next week, or not next week because we have 4th of July, so we're skipping next week. But we'll go over that the week after and when we talk about mapping. We're gonna generate this next with the, after the Plotly. And here's a little Plotly, and you can turn things on and off, high charter, graphs, and this is only a tiny subset. So this is just the showcase. You can go to the full gallery on this site and see this is sorting based on GitHub stars. There's 126 registered widgets. It is a lot. And so tons of cool, fun visualizations. Shoot. Guess my earbuds just went out on me. You know. Okay, so hopefully you can hear me still. Let me know in the chat, or if not. So thank you guys so much for helping explain to each other as we're going along here. And I'm seeing some questions about what is generated here. How do you see it? You can see it online. So if you guys knit this to HTML, it'll render into an HTML document. And actually, inside the default, when you render an HTML document, standalone is to bake all of the JavaScript and data into that single standalone file. So you could send it as an attachment. Somebody else could open it. What happens when you set this up as a website is that it actually stores all these JavaScript libraries in a site libs folder. So this is because of I have a site YAML that in my R3 exercises from our first lesson. Because of this, it's saving it in the site libs so that each web page can share the same site libs, and I'm not unnecessarily loading things I've already loaded before. So I might want to add manipulate from last week, so I can add that and point my website to it. And then I might want to add visualize this week. And then I can render the whole website by saying render site. And that'll also update the menu, the navigational bar on all the pages. So now I can look at this visualize in web browser and see, here's the output. And so far these are static, and now we get down here and now we're interactive. And this is, you can inspect and look at this, and this is all like JavaScript that is handled. It's like a little SVG, but you don't have to know JavaScript or CSS, but you can still render this stuff. So it handles that stuff for you. Okay, one other HTML widget that's certainly along the vein of marine ecological indicators is dygraphs. So let's just take a quick look there. It's another HTML widget, our library. And dygraphs doesn't have, it actually wants wide data, not long data. So that's fine. We can accommodate that because we've become proficient with manipulating data and going from wide to long and vice versa. So we can pivot wider to get the necessary data. And then this, it gives you another little slider by adding this die-range selector. So with very few arguments, we can just basically feed it this data frame. And if it's in the way, if the input argument of the data frame is in the expected format, then we get this back. So yeah, this gives you can also select it that way. And it just is slightly less cumbersome. There's like a lot more widgets. It's I would say a simplified view that's more time series oriented. So that's pretty straightforward to do. We can just copy this. Let's keep a little placeholder about where we're at and just finish this. Insert an R chunk, and then we'll grab this guy. And then once we get the data, then we'll actually generate the plot. Okay, so this first part is going from what is the long format, and then we're going to pivot those regions out into, we're just going to get the year because it wants a numeric value to begin with, and or this XTS object. So I don't even want to talk about that. It's a more complicated time series object. So we have year, and then California, Oregon, and Washington. We got there by using this pivot wider. And then once we define that, D region wide, we can then feed that into this digraph function. So that gets us this guy. We can still zoom in, and then I see those points on hover, or we can actually explicitly add a little slider on the bottom with this other digraphs function. So yeah, and then we can knit the whole thing. And then if I then save this and push it, then I have a website with all these indicators and even the interactive ones that I can then point other people towards. These DS stores are annoying on a Mac. You can just ignore those. So you can always right click on a Git file and say ignore, and it adds it to this Git ignore file. It's a hidden file, so it starts with a dot. And then I have all this stuff. So these are site libs are dependencies on that interactive visualization. So I want to select everything here to commit it and stage it and then push it. So I'm going to say, okay, plus visualize with HTML widgets with ggplot and ggplot2 and HTML widgets. A little commit message. Now I've committed everything. I don't have anything left in the Git pane. It's ahead by one commit, so now it's pushing. And then I should be able to go to my GitHub repo and see that, okay, 18 seconds ago it updated, and now I can go to the website for it, and it hasn't yet updated on GitHub pages. That can take a minute or 5, but it will. So I went over time, and sorry about that, but I'll share the recording sooner, and we have a longer period until next time, in which case we'll talk about spatial data and visualizing, reading, writing, and visualizing that using typical spatial data in vector format or points, lines, and polygons, and then the raster format using the raster package. We'll just give you a brief intro to those. And I know it's a little fast, but hopefully you can go back and watch the video, and there's more text in here for you to check out. And then also I want to say that I think people have been making some good use of the issues, not only for creating new issues, but also looking to see if any of the problems that you're having, somebody else might have had. And then you can look at these issues, especially the closed ones, and see, oh, okay, Git push, it's hanging, and oh yeah, that's kind of what's happening to me. And then here's a suggestion for instance, going into the terminal of your RStudio, and then executing Git push from there to get web authorization. So this is really, that first lesson is how we get to interact with the community. Tyler Murray, who's been really involved with the MBON, our Marine Biodiversity Observation Network, also came in here and offered a lot of tips. And I see people offering a lot of tips on the chat window. So yeah, we get by with little help from our friends and our awesome open source community. So I really encourage you guys to use these tools, take advantage of them, because I don't want to be the bottleneck. And yeah, with that, I will go ahead and let's see, let Kim direct me towards some of the chat questions that maybe are best to go over next and start into discussion.
Yeah, a lot of the questions have been answered by other folks in the chat, but maybe just
Great.
hearing things from another perspective. The difference between facet wrap and facet grid,
Mm,
when to use one
okay.
versus the other.
Mm-hmm. Okay. Yeah. So the cheat sheet is our friend there, and we can try these things. Excuse me. So the facet grid takes a regularized grid. So we have these little visual indicators of these things. So this is where we could say put the columns based on this variable, and then maybe put the rows based on a different variable. Or you could do both at the same time. So this using the facet grid is more complicated than what I was showing with just a facet wrap, which is just a single variable. And that allows you to arrange it by rows or columns, and even having two variables that you arrange according to each. Yeah, so uh, the facet stuff is great for looking at really highly dimensional data. And I'll just make a mention of this other pretty cool tool. Takes a little getting used to, but it's called Trelliscope.js. And if you have really complicated stuff, data that you're trying to visualize, um, it's it's quite cool because it does the faceting, but then you can even do filters and change your grid layout with another little HTML widget and get the count and mean. Anyway, it's its own beast. So that's for really going for it. Check out the Trelliscope package. Yeah.
That looks really cool. I've never seen that before. Um, when would you use geom bar versus geom call, like geom column?
Yeah, I did not do the best job explaining that. Because I get confused every time I go back and look at it too. So let's see. We have um, on that first page, when would we use geom call? So we used geom call for column, and it's because we had a discrete region and then revenue was on the y-axis. So it satisfies this criteria. And we also see that the aesthetics have an X and a Y. The geom bar here, we only see a, a single X, and the example is just a single discrete. So this would be the case where with geom bar, you might want to get like what's it's like a histogram really if you didn't. So this would be continuous, but let's say we have a count of like species, then you would just feed it aesthetic of count. And if we look at the geom bar help, so there's only one like directly mapped aesthetic. There's only an X really. And then there's this other thing that I didn't really talk about called stat. So it defaults to counting whatever you're sending it, but you can actually have other stats. So if we just have like, let's say we just want to get a count of the number of species, and we grabbed other data about, I don't know, um, the length and the gender, etc., on that observation, but we just want to look at species. You could do geom bar and it's going to default to the count. So each row has a different species, and some of them repeat. That's what it would do. It would give you a count per species. Um, there are all these other stats. So stat count, density, and other things that you can use. And I referenced these things that I didn't just, there's enough already here. I didn't go over everything to do with ggplot. That's its own course, but other things like I didn't specifically go over scatter plots, area plots, polar plots, how to change things with these stat functions and scale. But you can go here, learning ggplot. There's a whole online book on it. There's the R for Data Science, and then there's an R graphics cookbook. And there's really great resources here for doing deeper dives on ggplot. And yeah, so this is just to give you a little intro. But yeah, uh, basically, hopefully that answers and then some.
Awesome. Another question is, do you need a Shiny server to serve the interactive plots, or just simply uploading the HTML will do the job?
Mm. Okay, so this is actually, thank you for asking that, because this is a common point of confusion. When we say, I prefer using the words interactive and this is not universal, this is just kind of like my way of differentiating, but I prefer the word interactive to refer to online um, uh, visualization that uses JavaScript. So let's see, for instance, if this website has now changed. Okay, cool. So now my visualization is on my little R3 exercises website, and I can scroll down here, and this I would call interactive. So this is interactive. There is no Shiny server here at all. Um, it's it's that GitHub only serves, like, they call it static websites, because there's no backend server that is calculating anything. It's literally your web browser is requesting this file or maybe other files that it depends on, like in those site libs. And then your browser, your client-side browser, is doing all of the rendering. So this is my local Chrome browser that is doing all the rendering. All the data is sent to me, and we can actually even see the data. And then my browser is handling all that functionality with those JavaScript libraries that get loaded. So let's see if I can find it. Um, let's see, I'll look for year, let's see, 1999. Let's see if that pops up. Ooh. Okay, so this guy right here, this is actually where that data for this HTML widget lives in the source code of the HTML. So it's actually passing all of the data within that HTML file, and then the browser is doing the rendering. So yeah, that's why it does not need Shiny to render this. Now, why would you need Shiny? We haven't really talked about Shiny yet, but Shiny adds this server layer where you can have user input, then update things. And you could generate the same output here with Shiny, but let's say I want to have a drop-down box, or I want a subsample, like let's say the data is actually every minute for a 40-year period. If I sent all of that to the browser, it might be too big. But you can actually use Shiny to say, like, okay, only send this much to the browser. So Shiny gives you that backend server function, but then you need to host it somewhere, like on shinyapps.io. You can get 5 apps for free of limited CPU and size, etc. So it's good to know, like, okay, HTML widgets is for simple, dumb web servers, but you can also use that visualization in Shiny if you want to update what it's presenting based on some user input. Yeah, it's that we'll close that loop when we get to the Shiny, and we'll revisit some of these HTML widgets then. Yeah.
Awesome. This is a longer question. What if you want to plot a different linear model over the data? I know that there's some arguments that you can use for plotting GLMs, but what about something like stock recruitment or a growth model? I've always just created a new data frame of predicted values and then plotted that over top the raw data, wondering if there is a better, smarter, faster way.
Okay, that's actually a pretty good way of doing it. So the default for everything that I show, and this is a good question. Like when we were taking this geom smooth and adding a layer to it, if you look at this, there is this data, there's a mapping, and there is a data argument to it. So it's expecting a ggplot object that we're adding. But you can actually change the data, the underlying data that we're feeding it. And in this case, it's actually running a LOS or a linear model on the data for you. If you wanted to do that separately, if you don't, for instance, if the defaults that it uses with the underlying linear model aren't enough, like you want something more complicated from a stock recruitment model, you can use other plotting techniques and explicitly set the data to being a different data frame. And you can even set your own mapping and add that as a layer. So I think that's a more advanced kind of thing, but actually, quite doable. Um, so some of the other visualizations that you might use instead, like the geom smooth, basically it's adding a smoothing with a line and then adding a ribbon around that line here. So that ribbon, if you already have that ribbon, you can add that yourself. Where is that? It's called geom ribbon. That's not too surprising. There it is. So you can add your own ribbon, and that sets the Y min and the Y max and along your x-axis, and that's how you might do an upper and lower bound, for instance, on the original time series. You can also add error bars explicitly, and you can even add individual line segments and polygons of your own custom making. So you can use all of those and just add those layers with any data frame. It doesn't have to inherit the original ggplot2 data that you fed it. So thank you for asking that question. And if you want to look at, like, there's a library I started building for this. Has a, whoops, for the California Current IEA that has a custom ggplot function with its own custom ribbon and even a climatological mean. You can look at this reference. It's this plot TS or plot time series. And then if you really want to get hardcore, and I'll put this here. There's some visuals here. I'll put it in the chat. And then you can click on the source of that. And this is doing all this custom GG plotting. So it even creates custom little functions and runs its own model predictions and gets recent trends. And yeah, so yeah, anyway, there's materials there. You're welcome to steal and even create your own plotting function with that.
Another question is, where can we find the video recordings, I'm guessing, of these meetings? Can you point us to those?
Yeah, so I'm putting them here under the main page. Whoops, that's not the main page. It's on the main homepage, and it just is a little video link. So you can go to the first one or the second one so far. Hopefully you get ad-free, or anyway, there it is. Yeah, and hopefully you can see it in full size. So yeah, feel free to cruise back there and check out the video.
Here's another question. Do you have any advice on preventing the legend from being really wonky when making a ggplot into a plotly graph?
Oh, yeah. Yeah. Yeah, some of these things are can get a little wonky, and you can spend unbelievable amount of time just like trying to get things right. So this one came out pretty good. It's I guess I don't have any awesome tips right off the bat to yeah, to deal with it. If the legend becomes really problematic, depending on the complexity of your ggplot, output, then you might just be forced to write a more native ggplot, or excuse me, more native plotly output. So plotly has its own way of constructing plots, and you can use the R plotly to generate these plots. And sometimes, and see, this is how it has like an add trace. So it's its own separate way of doing this. So you might just look at this help on the legend to guide you, and you might opt to create a more native plotly type, I guess is what I would say. Yeah.
Thank you. Looks like we're right
Then,
at the end of our time. Um,
mm,
looks like these last couple of questions have been answered in the chat. So I just wanted to say thanks again, Ben, and thanks everyone for putting all those great questions in the chat. I'll copy and paste that into the notes so that way we can share all of those links that were put in.
all right, awesome. Well, happy July 4th to everybody. Yeah, I'll see you guys in a couple weeks. And I hope everybody's well. And thanks so much for all your participation, contributions. Bye for now.